Okay, so let's start 10.5. 10.5 notes is over harmonic series and P series. So a P series states that let P be a positive constant of the series where the summation of n equals 1 to infinity of 1 over n to the P power is equal to 1 over 1 to the first power plus 1 over 2 to the first power, whatever that P value is. Okay, notice it can only be a P series if the exponent P is a positive constant. So it can't be another variable and it cannot be negative. So it says the series converges if our P is greater than 1 and it diverges if P is between 0 and 1. Okay, remember, P cannot be less than 0 because that would make our P negative, and it no longer would fit the conditions for a P series. A harmonic series is a type of P series. It looks like the following. It's the summation of n equals 1 to infinity of 1 over n. So notice here that the P value for this harmonic series is 1. Okay, so when our P value is 1, you know it's harmonic. This pretty much just means that this is 1 plus 1/2 plus 1/3, etc. Okay, harmonic series always diverges. Okay, it makes sense because the P value is less than or equal to 1. Okay, for number 1 and number 2, it says, does the following series converge or diverge? Which means we first have to identify the P value in the P series. So looking at number 1, what is the P value? 3. Is that greater than 1 or between 1 and 0? So that means this series is going to converge. Okay, let's look at number 2. Okay, number 2, we have the summation of 1 over the square root of n. What's another way that I can write the square root of n? So this is 1 over n to the 1/2 power, which means our P is 1/2. Okay, and 1/2 is between 0 and 1, which means this series is diverging. Okay, so number 1 and 2 are pretty straightforward because they give you the P value. Okay, the other type of problems here, number 3 through 5, is saying what values of K will the series converge? So notice they don't directly give you a P value. You're going to either have to identify it in the problem or manipulate the problem to find the P value. Well, it wants the values of K to create this series that converges. So looking at number 1, okay, what would be our P value? 2k minus 5. That entire thing, just because that minus 5 is also in the exponents. Okay, we want this to converge. That means 2k minus 5 has to be greater than 1. So now we just solve for k. Okay, so the rest is just algebra. So I add 5 to the other side. I get 2k is greater than 6. Divide by 2. I get k is greater than 3. So that means for all values k greater than 3, this series will converge. Okay, so number 4, we have the summation of 1 over n times n to the power of 2k. So before we can solve for k here, we need to simplify this. So what's another way I can write n times n to the 2k? Not the 4k, no. Not 3k. Good. N to the 2k plus 1. So remember, our properties of exponents said if we have the same base, we can combine this by adding the exponent. So technically that first n is n to the first power. The second n is the power of 2k. They both have the same base, so I just add the exponents together. Okay, so that means p is equal to 2k plus 1. We want this to converge, so we need to see when 2k plus 1 is greater than 1. So then we just solve. First I subtract 1, I get 0, so 2k is greater than 0. Then I divide by 2, I get k is greater than 0. So this series will only converge if the k value is greater than 0. And then the last one, number 5, notice how this summation is different because what is in the numerator that's not in any of the other numerators? Good, and a variable. So if we look up at our definition of a p-series, notice that the p-series says that the numerator has to be 1. Okay, so we need to manipulate the equation on 5 so we have a 1 in the numerator. Okay, well, the easiest way to do that is to just divide every term by n. Okay, so every term we're dividing by n, which means we have 1 over, and then this part right here, this n to the 4k divided by n. Okay, remember, I can rewrite this as multiplication, but instead of this n being to the first power, it's going to be to what? Negative first power. So really this is n 4k times n to the negative 1 power, which we can combine as what? Good, n to the 4k minus 1, and then just bring over the plus 5n. We don't need to worry about that. We only care about the p-value. So that means our p-value is 4k minus 1. We still want this to converge, so we need to see when it is greater than 1. So I add 1 to the other side. I get 4k is greater than 2. Divide both sides by 4. I get k is greater than 1/2, which means that this series will converge when the k value is greater than 1/2. Okay, any questions on 1 through 5? Okay, so the very bottom of this notes, it tells you at this point you should be able to recognize if a series is geometric. Okay, remember geometric, this is a times r to the k power. Okay, where r is representing our common ratio. Okay, harmonic is the summation of just 1 over n. P series is the summation of 1 over n to the power of p, where p must be positive. Okay, so you have to be able to recognize each of these. You also need to remember the rules for the nth term test for divergent, okay, and the integral test. So remember, the nth term test for divergence states that if we take the limit of the summation, as long as we don't get 0, then we know that this series is diverging. Okay, it's in the title. Okay, the integral test is the integral test for convergence. Okay, do you guys remember what those rules were? The limit as n goes to infinity of the summation. So you take the summation and you convert it to an integral. Okay, and from there we're trying to prove convergence. Okay, perfect. You have to know at this point those 3 series and these 2 tests.